Hi guys, welcome to chapter 4. We're going to cover section A today, and we are getting into the earth itself and some characteristics of the earth that make it such a habitable place for living organisms, especially humans, to live. Okay, so keep in mind we're gonna go through this entire book with a biblical worldview. Okay, so a lot of this science stuff that we're looking at around us, we're going to keep those biblical lenses on. Okay. So in history, there was this Apollo mission from NASA, and they were the first astronauts to go to the moon. Their main goal was to get to the moon. Apollo 8 actually orbited around the moon, and when they got kind of to the moon itself, they didn't land on the moon. Apollo 11 landed on the moon. But Apollo 8 had this amazing view of Earth. You can see that picture there. They called it the Earthrise. And they broadcast live back to Earth on Christmas Eve. And these astronauts had a biblical worldview. They actually read Genesis chapter 1 to the people on Earth, talking about the creation, this verse in particular. And God called the dry land earth, and the gathering together of the waters called the seas. And God saw that it was good. So kind of cool. I can't imagine astronauts doing that today, but pretty neat back then. Just that reminder of your worldview, to keep it as a biblical worldview. And I think you'll be surprised at how well things fit. The scientific things and the observations, those operational science and observations actually fit with the story of creation and the stuff that we get in the Bible. Every aspect of the earth is linked to God's design. It's very specific to life, and he created it that way for us. Okay, so let's talk about the structure of the earth itself. The earth is massive, meaning it has a very high mass. It's 6 billion metric tons to be exact. It's more massive than the moon, which gives it more gravity than the moon. And it's just the right amount of gravity for the organisms that God created. Now, if God had chosen a planet or made us a planet of a different size that had a higher gravity, he would have created us to withstand that gravity. Or if he had created us on a smaller planet with less gravity, he made us to withstand the gravity that he created with the size of the earth. Okay. Not all planets are solid. Some are gases. Some of the outer planets in our solar system are gases, and we'll talk about that a little bit more in a minute. But the earth is solid, and it's actually constructed in layers. The outside layer is called the crust. And if you think of a hard-boiled egg, if you kind of crack the shell on the hard-boiled egg, that's very similar to what the crust of the earth is. It's actually cracked into several pieces that we call tectonic plates that we'll talk a lot more about in a further chapter. But that outer layer is the crust. In the next section, we'll talk about some of the deeper layers as well. The earth is actually tilted on its axis. So that's why a globe, whenever you look at a globe, it's kind of tipped over a little bit. And this is super important. The tip is at 23.5 degrees. So if it was up straight, if it was totally, straight up and down, that would be considered 0 degrees. If you measure the angle from 0 to the North Pole, basically, that's 23.5 degrees, okay? That tilt is what gives us the seasons, because it causes the sun to hit the globe at different angles at different times of the year. And we will talk about that a little bit more later. But you can see, let me get my pen here. Let's go with dark blue, okay? So you can see that the sun's rays up here are hitting the earth much more directly than, opposite. These are kind of glancing off. They're not hitting as direct of an angle as these down here, okay? So the way the sun is hitting the earth with that kind of tilt, that would actually be winter for the northern hemisphere and summer for the southern hemisphere. It's opposites, okay? We will talk about that a little bit more later. But if the earth was upright, if there wasn't that angle at all, the sun would be concentrated on this equator area, and they would never let up, okay? There would never be any highs and lows. And then the poles just would never get anything. The angle of the sun would be so weak that the poles would be even colder than they are during the winter now. And the middle zone, the equatorial zone, and kind of beyond a little bit, would be hotter than it is now, because there would just be no reprieve from that. So it would create these regions that would be less habitable than they are now. So the tilt is very important. The spin of the Earth, the rotation of the Earth is important too. That's what determines the length of our day. And right now, it's kind of the perfect length to modify our temperatures and the amount of sunlight we get. If it's too slow, the day gets longer, and that means the temperature goes up because the sun is hitting us longer. Okay, if it's too if it takes too long, that means you're exposed to that sun longer. Okay, but if it's too fast, we get less daylight. We're moving away from the sun quicker, and so we don't have as much time to sleep or maybe to hunt those nocturnal animals. And it would actually create more wind from moving through spinning as fast. Okay, not because we're moving faster, but because of the change in temperatures. We'll learn that temperature is what causes wind later on. All right, this is actually a picture of the Earth here. The Earth has a ton of water on it. About 3/4 of the Earth's surface is covered with water. That's actually a view of the Pacific Ocean at kind of a special angle, and it makes it look like the entire planet is nothing but water. No other planet has liquid water on its surface. Some have it deep down in the ground, but no other planet has liquid water on the surface. Okay. Living organisms need water. That's one of the requirements for life, basically. Okay, so it's important that we have that much water. Our planet is the only planet with a transparent atmosphere. Some other planets have atmospheres, but they're so filled with gases and dust and things like that the sun's light can't actually penetrate through the atmosphere. Our atmosphere offers us protection from meteors. Whenever you see a shooting star, that's a meteor burning up in the atmosphere. But it also blocks out a lot of the harmful radiation, the harmful wavelength of energy from the sun. But it does allow just a narrow set of wavelengths of the sun to come through, and that's what gives us light. It also allows us to get warm, and it drives photosynthesis. Okay, photosynthesis would not happen if our atmosphere wasn't clear and that sunlight couldn't get through. All right, the Earth also has this magnetic field that scientists really can't fully explain. They think it comes from the core of the Earth, which we'll talk about in the next section. But that magnetic field helps protect us from a lot of really dangerous stuff that comes off the sun. These things called solar winds and just a lot of radiation that comes off the sun, they kind of bounce around us because of the magnetic field that the Earth is producing. The sun itself is incredibly important, though, even though it gives us some of that dangerous stuff. It provides us with all of the energy on Earth except for nuclear energy. It drives photosynthesis, which you'll learn about in 7th grade, and it drives the water cycle, which you'll learn about later this year. And it is the perfect distance from the Earth to keep water as a liquid. If it was too close, the water would evaporate into a gas. If it was too far, the water would freeze into a solid. And it also keeps carbon monoxide as a gas. Okay, so God put the sun and the Earth at a perfect distance from each other for that to happen. And then the sun's gravity is what keeps us in orbit. We revolve around the Earth, and that's what determines 1 year for us. All right, now we're part of a solar system, and this is actually very specific to helping us also. God placed the planets in a good spot for us. These planets out here, I know I've got a dark blue marker, it's harder to see, are called gas giants. They are not solid, but they actually help us. They're orbiting farther out from us, and their orbit and the moons surrounding those planets help protect the Earth from objects coming in from outer space, like deep outer space, like comets and things like that. Okay, gravity from those outer planets are very big. So the gravity protects us from this thing known as the Kuiper belt. I'm not really sure how to pronounce that, but it's an asteroid belt that's farther out here. Okay, there's also an asteroid belt. Let me switch colors here, it'll be a little easier to see. There's also an asteroid belt actually called the asteroid belt right in between Jupiter and Mars there. But this one out on the outer edge of our solar system doesn't harm us because the gravity of those large planets kind of draws those in. The gravity of Jupiter itself, here's Jupiter, keeps this asteroid belt kind of drawn to it. So instead of these asteroids coming in and hitting us, the gravity of Jupiter pulls them and kind of keeps them in that tight orbit there. Okay. Now, this is just our solar system. This is the universe. This is not the whole universe. This is our galaxy. This is the Milky Way. Okay. And our position, so there's our sun right there, which puts us kind of in this location, that little tiny X there. Okay. Also a very specific, special location. We're far enough away from the center here, which is, crazy black holes and exploding stars, that we stay in that spot. The gravity affects us, but it doesn't draw us in. And then we've got these arms that kind of come off from the center. These arms are filled with stars. Our sun is part of one of those arms. But there's a lot of exploding stars in those arms right there. And so the Earth itself is kind of between a couple of arms here. So we have the gravity that keeps us where we need to be, but we're far enough away from those exploding stars to be safe. A lot of stuff that would have had to have happened completely by random chance in order for us to be in such a proper location and in order for the Earth to be just the right place for human life. I think it points to a designer myself. I think it speaks to God's creation. But I've got those biblical lenses on, right? All right, you guys, that's a long one. Talk to you later.